Hello everyone, let's continue with our discussions on Newton's laws. So this time we are tackling Newton's second law of motion, and it states that the unbalanced external force acting on a body imparts an acceleration which is proportional to the applied force, and the direction of the acceleration being the same as that of the applied force. So this is just the continuation or just the extension of our first law. Because as what we have discussed in our first law, that if all the external forces in symbol, the summation of all the forces acting on the body is equal to zero, meaning balance each other, then the state of the body, the motion of the body being at rest or in constant motion is preserved, meaning there is no change. But what if there is an unbalanced force? So this unbalanced force, or the if net, causes an acceleration to the body. So this acceleration is directly proportional to the magnitude of the net force. And how about the mass? The mass is inversely proportional to the acceleration. So again, if net is equal to or proportional to the acceleration, meaning the greater the if net, the greater the acceleration, or the rate of the change of the body's motion, provided that if net is not equal to zero. And then the acceleration is inversely proportional to its mass, meaning for greater mass, the lesser the acceleration of the body. And take note, we need to emphasize that the acceleration and net force should be in the same direction. Replacing the proportionality sign by the equality sign, equation becomes F net is equal to K M A, where K is our proportionality constant. M is the mass of the body and A, the acceleration. So this equation will be made simpler if the proportionality constant K is made equal to unit T. So this can be done with the proper choice of units. This means that we can define a unit of force when K is equal to 1. So with the constant equal to 1, then our F becomes equal to MA. The units is equal to kilogram meter per second squared, and this is the Newton, or simply N. So this is now our equation for the second law of Newton, or the if net is equal to ma. So example, we have this illustration that a given mass m resting on top of a horizontal surface and then acted by these four forces as illustrated. The summation of force along x is not equal to 0. Sample, F3 is greater than F4, F3 to be equal to 5 newtons, and then F4 equal to 2 newtons. So the summation of forces is equal to F3 minus F4, since opposite in direction. This is equal to, of course, not equal to 0. So F3 is 5 newtons minus 2 newtons. So this is equal to 3 newtons. So this 3 newtons is our if net. And this if net causes our mass to accelerate with this magnitude equal to ma. So if mass is given, then you can solve for the acceleration of the body or the mass. So this is equal to F net over N. So if our F net is equal to 3 newtons, this one, therefore, the summation of forces along vertical axis y is equal to 0. Because our net force, the unbalanced force, happens in our horizontal axis. So therefore, F1, again, the same with our sample in first law, F1 minus F2 is just 0, or F1 equals F2, meaning the two forces along vertical balance each other. So our net force in this system, or the net force acting on the body, is just equal to 3 Newton, and this direction is positive, so meaning it is towards the right direction, because the acceleration follows the direction of our net force. So the body also accelerated towards the right.